So, combo method here, when we go to solve a rational expression or a rational equation, with what we've been doing, with finding LCDs, sometimes we factor, sometimes we get to cancel. So here's what we're going to be doing kind of in a nutshell. I'm going to write it up here at the top so we can kind of know what we're up to here. All right, so once you've got an LCD, a least common denominator, I guess I should put A because and this doesn't start with a vowel, but that's okay. So once we have an LCD and build our fractions, and there is one other way around this, but I still going to have to find that least common denominator or multiple anyway. So once we have that, once we build our fractions, we're going to wipe out the denominator and solve what's left. Now, some of you may look at that and go, well, wait a minute. Didn't you say yesterday we can't touch the denominator until the very end? Now you're telling me I can. But we're doing something different. We're doing equations now. We're trying to solve for something. So the rules can change a little bit depending on what it is we're attempting to do. So you'll kind of see that as we start to work through these, and I'm going to keep referencing back to our help sheets again to kind of make sure that everything's going okay with these. So I get to this first one, and I go, okay, first question. Actually, let me pull this out already. Okay, what's my LCD going to be for number 1? So, again, right now I only care about the denominators. Coefficients, yep, they're both 3, so I'm just going to jot this down here. So 3, okay. Any single variables? Yes, those aren't attached with a plus or minus. We always just take the one with the biggest exponent. Well, they both have the same exponent, so it really doesn't matter. And then I don't have any sets of parentheses. So that's my LCD, and this is how this is going to work. Once I know that, I'm going to go ahead, and you're going to think this is pretty slick how quick this is going to work out for us here. My initial values all stay up in the numerator, but now I'm going to have a common denominator, which very quickly is going to disappear. So I get that out of the way, and I go, okay, fraction builder. What do I have to multiply x by to get to 3x? 3. So we get that up there. What do I have to multiply 3x by to get to 3x? Nothing really, or if you're one of those, you like to put something, okay? If it's nothing else, we can put a 1 there. And then one more time here at the end, 3 to get to 3x, I need x. Here's the cool part though. Since it's an equation, here's basically, I'll show you what we're actually doing so you're not just like, woo, I wish I could do this on everything. If I wanted to solve the equation, I'd want to get rid of the fraction part, right? Nobody wants to deal with a fraction. So technically what I would do at that point is I'd multiply through by this LCD, by 3x. Well, by doing that, it's going to cancel all of those out. So once you have this part done and your fractions built, the denominator is going to go away. And whatever's left from each part, 7 times 3 is 21, 1 times 1 is 1, 5 times x is 5x, and now I just solve what's left. It's basically turned into something that looks complicated into a pretty simple Algebra 1 problem. So, let's get this solved up and figure this out. Now, there is one caveat, one danger with this particular section is, and that is occasionally you're going to get an answer that doesn't work. So you notice here it says make sure to check your answers, but I like to look at this a little bit differently because there's kind of a trick you can use here. Instead of having to plug in the 4 and then deal with the fractions, who wants to do all that? Here's basically the only rule you need to watch out for. 0 in the denominator is bad. In other words, as long as the value that you find for x doesn't make the denominator of any of your fractions 0, your answer is okay. So I go back and I look, and I'm like, okay, well, if I plug a 4 in there, that isn't 0. 3 times 4 isn't 0. And that's a number. I don't even have to plug anything in. Okay. This one works out all right. Now, if I plugged every single one in, yeah, it comes back, it checks out, I get equality. And you can do that, but I know a lot of you like to find ways to kind of quicken things up a little bit. Now, I'll warn you, this next one, we're going to take up some room. So we're gonna scribble out number 3 here right away. We're going to take up that room, too. Like, dang, that's a lot of room. But sometimes that happens. So, okay. First things first. Denominators only. Are any of them factorable? Yes. X plus 2, x minus 2. If you ever have a denominator that's factorable at the start, you need to do that. Because then when I go to find my LCD, I'm not going to get myself into trouble. So I look and I go, okay. Again, if I see plus or minus, I'm going to parentheses. And then if I need to, I'm going to go to my help sheet. There's nothing wrong with that, that's what we got it for. Are there any coefficients out in front? Nope. Because again, we're only looking at the denominators. Are there any single variables that aren't in parentheses? Nope. So then, different sets of parentheses. Again, if I see it more than once, I don't have to use it in my LCD more than once. Okay, so when I see the x minus 2, that covers both of these. The only way I'd need 2 is if there was 2 of them in the same fraction. And then I see an x plus 2. Oh, nothing else is left. Okay, that must be my LCD. But remember, this LCD is only going to be here temporarily. Because once I build my fractions here in a second, I'm just going to wipe those away. They're going to go and just kind of disappear, which is what I know you'd like to do with a lot of this. But again, just keep reminding yourself, old denominator, new denominator, whatever is missing. I've got the x minus 2. I check that off. But I don't have the x plus 2. So that's what I have to put up top. The second one, I've got the x plus 2. I don't have the x minus 2. That's what goes up top. And then the last one, that works out pretty cool because I have everything. So again, if you want to put a 1 there, you can, but I really don't need anything in this case. So once I've used my LCD to build my fractions, to build my numerators, it has done its job in life. I don't need them anymore. I just kind of throw them off to the side. They're useless to me. So once I do that, now I'm going to go through, I'm going to distribute, I'm going to combine like terms, I'm going to do all that other fun stuff. So I go, okay, little side work here, probably in order. Grab this. Again, because I like to save a little bit of room. So I'm going to distribute this out, which would be 3x squared plus 6x. So I'm just cleaning this up here. And then here, I got x minus 2. So you're like, okay, so what have I actually got with all this stuff? Well, let's see. I've got 3x squared, 6x, and 1x is 7x. Minus 2 equals -4. Now again, if you want to write that step out, instead of doing the side distributing, write that out and then combine like terms, that's okay. It depends on the person. But whenever I see an x squared, whenever we see a quadratic term, we've got to get all the terms to that side because we're going to have to factor it. So we're going to add that 4 over. We'll kind of move up here. because we want to get to something that equals 0 so we can actually get this solved. Now, at this point, we've got to do some factoring. Now, this is just me. You can tackle this how you want to. I know some of you automatically will go to slide and divide on this, but here's where I'm saying you might not necessarily have to go down that road this time. You can still, but if you think about it for a minute, if I just tried to straight factor this, what can I multiply to get 3? 3 and 1. Okay, there are no other choices for that, so I don't really have to think about it much. I'm going to have my numbers multiply to get 2, positive 2, and I see all pluses, so I know that's plus. So really my only choice now is, because how do I multiply numbers to get 2? Well, 2 and 1. Well, where do I put which? Well, if I put, I'm just going to do this really lightly. If I put 1 here and 2 here, would that work? 1x and 6x is 7x. Okay. Now again, if you're more comfortable, okay, if you're like, Harty, I am a creature of habit, quit making me do this differently. I just want to do slide and divide, just so you see that it works the same way. And some of you may have done this already, and we're like, forget you and your other way of doing this. I'm going to keep doing it my way, which is fine. Okay, if you're continuing to go the slide and divide route, I'd move that down. I'd say, okay, multiplies to 6 and adds to 7. All right, that's 6 and 1. I'm good there. But don't forget, if you do it the slide and divide way, which again, if you've got your help sheet, there's an example of how to do slide and divide on the back of it, just in case. Cheap plug for the cheat sheet. I divide that number back out, and if it goes in even, great. If it doesn't go in evenly, I can take that value and swing it back to the front as long as that fraction's been simplified. So I get the same thing either way. It depends on how you want to do it. This is going to go quicker if I can do the mental math though, because sometimes you got to do a lot of this when you're doing it. So just something to consider. And so you're like, okay, last part. Once we get it down to the parentheses part, set them equal to 0 and solve the mini equations. But, like, dang. Before you circle it, remember, 0 in the denominator is bad. So let's look back at our denominators for a minute. If I plug in the negative 1/3, does it cause a problem? Negative 1/3 minus 2, that's not 0. Negative 1/3 plus 2, that's not 0. So that's okay. Okay, so that one's good. Negative 2. Negative 2 minus 2 is negative 4. That's okay. Oh. Negative 2 plus 2 is 0. Bad. Doesn't work. Because it causes 0 in the denominator. We can't divide by 0. That's undefined. So that's what I mean by saying when you get to the end, before you circle, make sure that it's not causing you a problem. Okay, bless you. That's as bad as it gets. So that's the worst case, not the worst thing ever. Okay, 4 looks complex. All right, not really though. If something's not a fraction and I want to make it a fraction, what goes in the denominator? 1. Okay. So I'm just going to make everything a fraction so I don't get confused. So then, my LCD. Run down your checklist. Coefficients? Yes. Single variable term? Yes, but again, you only take the one with the biggest exponent, which is just x, or x to the first. Don't times them together. And there are no parentheses this time. So my job to get all of these with something over 3x, because then I'm just going to wipe it all out. So let me get what's on top of each of these in here. And if you write big, we're not going to do 5. We're going to jump up to 6 next, so no worries. And again, I start the building game. Whatever's in the old one, what does it take to get to the new one? I got the x. I got the x. What didn't I check off? The 3. Okay, to get from x to 3x, we got to have a 3. What about to get from 1 to 3x? I need it all, 3x. And it's going to be the same on the next one. And then on the last one, I really don't need anything, but if I want to put something, I can put a 1. Again, once I have that common denominator and have rebuilt my numerators, get that out of there. Let's see what we got left. 9 plus 36x equals 6x plus 4. Now at this point, you can choose to do this however you'd like to. I normally like to get all my x's together first and then kind of work it from there. So I'm going to go ahead and minus the 6x from each side. And now I got to isolate my x's so I can minus the 9 over. And here's where I got to be careful, because in the past, some of you have gotten into a problem like this, and you look at that and you go, ooh, 30 divided by 5 is 6. The answer is negative 6. No, it's not. Because when you divide by what's with x, the bigger number's on the bottom. It's in the denominator. So this is going to be negative 1/6. It's going to be a fraction. Those are the little points that some of you miss on quizzes and tests that are going to cause some issues. And then, good, because here, negative 1/6, that's not 0. Is 3 times 1/6 0? Nope. So that one actually works. And I can kind of work it that way. So I'm like, okay, I might be able to make this work out. This isn't too terribly awful with what I'm trying to accomplish. So let's see here. Do I want to do one more of these? It's probably not a bad idea. Let's do 6, just to make sure, before we get into some little bit more craziness here. What's my LCD going to be for 6? 2x. Ooh, that was like in stereo. I like hearing that. All right, so let's see here. And again, it's all about this. This is right here what we do. This is the critical step every time on these, because if we don't get this right, we're in trouble. X to get to 2x is a 2. 2 to get to 2x, I need x. And from x to get to 2x, I need a 2. Adios, denominator. Thanks for helping us out. Don't need you anymore. 6 minus x equals 24. Be cautious, because again, when you minus the 6 out of there, because that's what I got to do, it's like a plus 6, so I got to minus the 6. You're not done, because you still got a negative in front of your x. So we're just going to divide by negative 1 to take care of the negative part. And since it's just x in the denominator, negative 18 definitely does not equal 0, that one's okay. And a super majority of the answers you get are going to be okay. You might get like 1 every 6 or 7 problems that may have a bad answer. So we've just got to double check that. Now, we get to part 2. You start to go back a little bit like we did up in number 2. We're going to solve this equation with 2 solutions. Make sure to check answers. Again, make sure you don't have a denominator of 0. So let's say we do number 7. All need to be factored, because I don't want to make this huge if I don't have to. So again, I look when I'm looking at factoring, if I see two terms, I always want to make sure if it's not a square or a cube right away. Because if it is, I got a form right here for that, and I can fix it. So, what's our LCD going to be? You can take up number 8 space. I'm purposefully going to kind of eliminate the middle ones here. X plus 1, x minus 1. So if we need to spread out a little, we can. Again, even that 2 in the middle that we don't really think of as a fraction, we're going to treat it like 1. So let me get what I've got initially up here. And we're going to use a little common sense this time. We'll see if this clicks or not. So I get my LCD, I get my numerators all rewritten. What do I need in that first fraction? X plus 1. Now, the second fraction, let's think about this for a minute. You're like, well, I need everything. I'm just going to write x plus 1, x minus 1. And you could, but let's think a little further to make this easier. We got the x plus 1, x minus 1 from this, where it was x squared minus 1, right? I can just write it in here that way if I want to save myself a little bit of time. If I remember, oh yeah, that was just this factored, and I'm just going to rewrite it out anyway. If I wrote it as x plus 1, x minus 1, I'd have to do the box on it, which isn't the worst thing ever. I'd just get this back. So, just an option. And then my last one, I got everything. So it's just the 1. Again, kind of feel bad that I'm just keep using the denominator here, but that's just the way it is. So denominator gone. And I start to look at this. I'm actually going to write it all out this time instead of trying to do my little side work because there's enough congestion going on here. So 5x squared plus 5x, because I got to distribute to both, not just the first term. Careful, we have a minus in here this time. If you think back to when we talked about this before, what we normally were doing was just moving the negative up here so I didn't forget about it when I distribute that through. So negative 2x squared and plus 2. And then 14 times 1 is 14. And just like we had before up top, combine like terms and get everything on the x squared side. So 5x squared minus 2x squared is 3x squared. I only have one x term, this 5x. And then, okay. Well, let's go ahead and go crazy and do everything. So 2 minus 14 is negative 12. And again, I've got to factor this. And again, whether you're doing it mentally, whether you're doing slide and divide, whatever it happens to be. Okay, if you go the slide and divide route, do a little side work here. You're like, okay, I slide that 3 down, I'd have x squared plus 5x minus 6. And I'd work that out. And again, I've always got clues with any factoring problems that I do, which would make this work really well. I know it's a negative product, so I know it's one positive and one negative. Okay? And 9 and 4 are 5 apart, which is exactly what I'm looking for. But remember, again, our one caveat with slide and divide is I've got to remember that number that I slid back at the beginning, because I've got to divide that back out. So let's see here, x plus 3. 3 doesn't go into 4, so that goes back to the front. And now I just set those two sets of parentheses, my factored form of this, equal to 0, and see if my answers work. So for time, well, not for time's sake, but for space sake, I'm going to write this down and get you to the answers for both of these. And I probably shouldn't have been quite this confident as I was looking to see how this was going to work out. So I look and I go, okay, let's see, where would be my problem? 1 would be a problem because 1 minus 1 is 0. Negative 1 would be a problem because negative 1 plus 1 is 0. But neither of my answers are 1 or negative 1, so I'm okay. I'm good. This works out. So you're like, okay. Harty, this is just kind of... Okay, let me okay, remember, I'm looking at my denominators when I'm trying to see if an answer is going to cause me a problem or not. So if I look at this, I'm like, okay, what number would I plug in here that would cause a problem? 1 would cause a problem, because 1 minus 1 is 0. If I look at this one, negative 1 would cause a problem, because negative 1 plus 1 would also be 0. So my problems here would be if x equaled 1 or negative 1. But since neither of my answers equal one of those two, we don't have any issues this time. Gotcha. So yeah, that's what we'd be looking at as far as those go. Now, actually then, we're going to get to most of my students' favorite part here at the end, at least if you could call something a favorite part of this. If, big if there's only one fraction on each side of the parentheses, you can cross multiply to solve these. You won't even have to find a common denominator. So, for instance, I'm going to put my parentheses around here still. So no extra plus or minuses on each side. What I'm going to do is I'm going to cross multiply. Now you're like, could I find an LCD still and keep doing it the same way? You certainly could. But you don't have to in this case. So I would cross multiply and then I could distribute and just work out what's left. So again, I got to get all my x's to one side, all my constant terms to the other. So me, I'm going to minus my 2x over. Subtract the 6 back going the other way, nice. And divide by 2. And again, before you circle it, look for a second to see what would cause a problem. 2 times negative 8 is negative 16 plus 3, that didn't equal 0. Negative 8 minus 5, that doesn't equal 0. Okay, I'm good. But just kind of keep working those out that way. So, all right, I'm going to end with the big kahuna here on 12. Well, at least it's going to seem that way. You're like, man, with all of those, are you saying, do I have to box or foil all these out? Yes. Okay, you can't just multiply 3 times 4 and 1 times 13 and call it good. That won't work. So I'm going to use this as my side work for number 12 over in this area, because what I'm going to have to do is we're going to kind of double box this guy up. So I'm going to have 3x minus 1 and 4x minus 13. And again, it's just like if you're foiling. You're just multiplying what's on the sides of each of those boxes. And then once you multiply to fill the box, now we're just combining like terms. The multiplying part's over. And you're like, oh, this is going to get, these numbers are going to be huge. This is going to be ridiculous. I quit. No, there's none of that. And then again, I just box or foil my other And again, multiply your coefficients, add your exponents as you're working your way through. And something very nice is going to happen for us here. You're like, what looks nice about that? I'll tell you what looks nice about that. We talk about how we want to always get all of our x squared terms to the same side, right? What happens when I do that? They just cancel out, because if I minus 12x to each side, so now it's back being easy again. Because now again, I'm just going to, let's see, how do I want to do this? I'm going to actually add my 43x over. Yep, add that 43 on over to the other side. I'm going to add my 10 back this way. And again, don't get sucked in. What am I going to be dividing both sides by? Yeah. And again, bigger numbers in the bottom means I'm going to get a fraction for an answer. 1/3. But before you circle it, make sure it doesn't cause a problem. So let's see. 6 times 1/3 is 2. Uh-oh. 2 minus 2 is 0. So it ends up, since my one answer doesn't work, it ends up being no solution. Okay. So here's going to be your choice of task in this. Okay, we will be doing this again tomorrow. So it's not one of those we're going to do one day and skip along. We're going to see it again. But up at the top, I do this every once in a while. There's a choice up there. There's 3, 4, 5, 6, 7. What was that? 9, 4. 6. Yep. 9 problems out of the book on 546. Or you can flip over to the back and do the worksheet. But some of you are already doing the mathematics of this. There's more problems if you do it on the worksheet side. Can't see my smiling face on the internet. So either one of those works. And again, tomorrow it'll be back where we've got some more work time working through some more of these before we start tackling story problems in these on Thursday.